All right, I wanted to continue talking a little bit about inheritance, of course. Let's take a look further. Let's see. Let's go back up a little bit. We did cover dictionary and book, the second version. Let's talk about overriding. And I think a picture will give you a good idea too. Take a look at this picture down here, where we call the class hierarchy. So we have a very general class that would be the parent class, the super class, the base class, and then you have the children classes, and then you have also the what we call also the child. What we said the child class, also the base class. No, the derived class. Sorry, and subclasses. Sometimes they might call that in Java, but generally it's used for the C++. So when we looked at methods and our constructors within a class, whenever we had the same method or constructor with the same name, of course a constructor, but a different argument list, we call that a override, overloading. But now when we're talking about inheritance, in which the child class can actually change or add information to the method, that's what we call overriding. So it's going to take the parent's definition of the method and make some changes. You might be able to add to it or totally change it. Now, if you should totally change it, I would say that that would be silly to actually call it the same name as the original, as the parent method. That would not be the purpose of inheritance. Inheritance is to take what is there and enhance it or make it more specific of the class, of the child class. Now, again, be careful with the language because take a look over here. Constructors are not inherited. You can, they have to be part of your implementation. And like we saw before in book 2, we have to give information, we had to pass information to the parent class for the instance field that it requires. And we use the super keyword. So if the parent class, and if we go up, we can see the parent class over here. The parent class is taking an input argument. So that means that whatever is actually using that as a superclass, parent class, base class, then the child class has to give that information to the parent class. Actually, this is one of the most common errors that students have, which is when the parent class has an argument or argument list, sorry, right here, and the constructor or the methods, actually, it doesn't matter, then it has to be supplied to the constructor. Let's take a look at, let's go back down here and let's keep on track. So since you're not inherited, and that means that you have to use it the way it is. That's the difference between a constructor and a method. A method, you can change it, the whole body, but the constructor, you don't. What you do is you add to it. So you give the information that is required as an argument list, and then you take it from there. Let's take a look over here. So if we look at book 2, the constructor has only pages, but dictionary, it looks like it's adding something else to it. Do not try to override a constructor that doesn't do anything different. That's kind of pointless, and it shows that you don't understand inheritance. You can do the same thing with methods. And again, it is a key object-oriented design type of element because what you're doing is you're reusing the actual code. And the idea behind inheritance is it's actually very smart. You start with a very bare class, which is the parent class. And then the children could all be different in many ways, except whatever they all have in common. And that's when you do the overriding. Method overriding allows two objects that are related by inheritance to use the same name. Generally has the same task, but in different ways. If a method is defined final, then it cannot be overridden. Yes. So when it comes to designing with inheritance, it's because you want a specific structure or formats for your classes. So you kind of force the actual children classes to have a very specific format. So if you use the word final, that means that you must use the method the way it is, and you cannot change it. So that's imposing a format, a design. You can also have a class that is final, like for example, strings. A string is a class that you cannot change. All the classes that come from the library are have a final access modifier, so you do not change it. And as a matter of fact, you cannot even extend it. And here it is. It says right here. What's shadowing? Okay, so shadowing is actually something very interesting. Let's see. Um, so think about a class that you've seen already, and actually we can use whatever we have over here. I like to talk about the bank account or the accounting for this book, but let's look at something that is available at the fingertips, just for something like book two. You have an instance field called project pages of data type int, and you technically cannot touch that instance field. It belongs to the parent only. You can use it. You can have access to it with the super keyword, but you cannot make changes to it. Okay, the same thing with, it's just pretty much the same as with constructor. They cannot be overridden. It means that you can use it, you can add some other things that maybe somewhere else you can access them together, but you cannot change what it is. So if that's the case, what happens if I have another, I have a child class? Let's take a look. So we agree that in the book 2 class, we have pages. If I declare over here, create an instance field called also pages, that will be shadowing the actual parent class instance field. And you can have a little bit of conflict over there because depending on which kind of object you are creating, if you create an object of book 2, it will use pages from book 2. But if you create an object of dictionary 2, it's going to be using pages from book 2. And if you're trying to reconcile the two numbers, the two variable values, then it's not going to happen because they're in two different planes. So let's go back down here, and that's what we call shadowing. So in the child class, you shadow the actual parent instance field. And one typical example is the bank account. If you think about the bank account in which you have the instance field called balance, then if you create an instance field in a child class like savings bank account, then and you use balance also there, you create the new instance field, you might have two methods, one that's inherited and the other one that's overridden in the child class, and they both are talking to two different balances, and that would be a real problem. So at all cost, that should be avoided because that could cause major problems. That would be a good activity. Let's take a look at what's over here. So there's a whole bunch of things over here that I extracted from the whole chapter. There are some methods that must be overridden in the child class. So you have access to them from object class with the uppercase O. And as we talk about it many times, even from the previous class that you took, we always overrode toString for sure. We define it according to the actual ADT. So it has that relevance instead of giving you just, a kind of gibberish type of printout. So if you created a toString method that it was related to the actual ADT, then when you printed the object without using the method toString attached to it, then you would get relevant information. Okay, so last thing that I want to talk about is about abstract classes. And again, in terms of they're strong in terms of designing. They're not that popular because it definitely takes up space, storage, if you want to call it, and also extra time in designing them. But the idea behind abstract classes is to have this overarching idea. And so all the children classes will follow the same pattern, the same philosophy, if you want to call it, the same format. So an abstract class you cannot instantiate any object of the abstract class, means you cannot create it. That means that also you have to extend that class to create children classes. This is a very good example. You have vehicle, which is very general, and think about what is common to all the vehicles. In this case, we have a car, a boat, and a plane. So if you think about what is really common to those three children classes, that's what you would put in the abstract class vehicle. And then if you wanted to create any other, you will have to force them to actually extend vehicle, and you will be creating object of these classes over here, never of vehicle, because it would not make sense anyway. What's a vehicle? I mean, when you talk about a vehicle, you really specify what it is. You don't say my vehicle, you say my car. And then you talk about things that are related to the car. And the same thing goes for the other two. So what are the things to know about that? Now, this is very rare to show up in the AP exam, but it's good to know. And when it comes to designing and implementation, you want to be aware of these features. So in an abstract class, you have to override all of its parents' abstract methods. Not all the methods have to be abstract. You can have just only one and the class becomes abstract. So that means that if you just implement the methods that are abstract, then you're good to go. And that when I say that, I mean all the children classes of the abstract class will inherit. Now it will be a concrete class, and it will inherit all the methods from the abstract class. And all you have to do is any method that has nothing implemented in there, or if it has something implemented in there, you want to add more to it and make sure that it's not abstract, meaning remove the keyword abstract. So you haven't seen interfaces, so we cannot talk comparing, so we're going to leave that alone. Let's see, it will have an abstract modifier, meaning a keyword abstract. What else? Class does not contain abstract method. Abstract serve as a placeholder. Yes, so a placeholder in a class hierarchy. So what you have over here is a class hierarchy. And as you can see, when you actually create an abstract class in BlueJ, it will ask you if it is abstract or not. So it will give you these interesting angle brackets. And it will create that. Let's see, what do I have over here? Here it is. So somewhere in there, in your BlueJ, you will get, let's take a look. Here it is. You create an abstract class. All right, let's go back over here. Yes, make sure that you, like I said a few seconds ago, you have to implement all the methods that are abstract. Otherwise, it will be considered also an abstract class, and that in turn means that you cannot create any object of it. Here's another thing that to know. You've seen a couple of videos on the static, and we just talk about final. It prevents you from extending any classes, meaning there are no children of a string, let's say. There are no children of an integer class, an integer ADT. Because of that, it doesn't make sense also to use the static specifier or modifier, right? Think about it. Because static is something that is used for concrete classes. And it's actually, it becomes active as soon as you create an object of that class. And since you cannot create objects of an abstract class, then that doesn't make sense. And that's the second part of it here. All right, so this is all I wanted to say about this very abstract, very theoretical component of this device that allows you to have a nice way to design classes, ADTs. You might not think it's that important, but when it comes to designing systems, actually this becomes a real good component. Having the ability to create abstract classes in which objects cannot be created until they are beta defined, it allows the designer to force anybody else who's actually designing the children classes to follow a particular design that started with. All right, so that's pretty much all we need to talk about abstract. However, remember the little things that I had bullets for, you should know them. And know them in terms of what they mean. It's not a memorizing thing. It's more of understanding what abstract is doing. And then things will make sense. All right, that's it for now. Bye.